Next is we are going to interfacing ultrasonic sensor with ESP32 to calculate the distance. So first, what is ultrasonic sensor? So an ultrasonic sensor is a type of sensor that uses sound waves with frequencies higher than the upper audible limit of human hearing to detect objects and measure distances. These sensors typically consist of a transmitter and a receiver. The transmitter emits high frequency sound waves which bounce off object in their path and return to the receiver. The time taken for the sound waves to travel back to the receiver is used to calculate the distance between the sensor and the object. So, ultrasonic sensors are commonly used in various applications such as industrial automation, robotics, automotive, security systems, and healthcare. They are preferred over other distance sensing technologies such as infrared sensors because they can operate in a wider range of environmental conditions and can detect a wider range of materials, including transparent and opaque surfaces. So how does this actually work? The ultrasonic transmitter, which is trigger pin, emits a high frequency sound. The sound travels through the air. If it finds an object, it bounces back to the module. The ultrasonic receiver, which is echo pin, receives the reflected sound, which is nothing but echo. So using this sound's velocity in the air and the travel time, we can calculate the distance to an object. So the formula is this. So the distance to an object is equal to speed of sound in the air. It is multiplied by the time and the whole value is divided by 2. The speed of the sound in air is 343 meter per second. So now let's move to the code. So let me open it. Let me erase it first. Okay. So first what I am going to do is, first let's define the trigger and echo pin. So, constant integer trigger pin, let's give 5. Echo pin, which is 18. Now I am going to define the sound speed. So define sound speed, which is 0.034. So the sound speed variable saves the velocity of the sound in the air at 20 degrees Celsius. So now let's define centimeter to inch. We are going to use 0.393701. So centimeter to inch variable allows us to convert distance into centimeter to inches. So now I am going to initialize all the variables. So first long duration. So it saves the travel time of the sensor. So now float distance centimeter. It saves the distance of an object in centimeter as well as distance in inch. Now coming to void setup, I am going to start with serial begin. Which is 9,600. And then I am going to mention the pins and more. So trigger pin is output pin. Echo pin is input pin. So yeah, serial begin. So inside void loop, here I'm going to generate the trigger pulse first. For that, what I'm going to do is digital write first make trigger pin low, and let's give delay of in microseconds. I'm going to give like 2, and then again I'm going to make trigger pin high now. So delay microseconds of, let's give 10. So now I am going to make trigger pin low. So this will generate a trigger pulse. So low. Yeah. So then I am going to calculate duration. So duration is equal to pulse in of echo pin, and it's high. So what this means, pulse in function reads a high or low pulse on a pin. It returns the length of the pulse in microseconds, and the pulse length corresponds to the time it took to travel to the object plus the time traveled on the way back. So now let's calculate the distance. So distance in centimeter is equal to duration into that sound speed. So that is divided by 2, right? So now I am going to calculate the distance in inch. For that, distance centimeter into centimeter to inch. So now I am going to print the distance. So serial dot print. First let's give distance in centimeter. Okay. Now serial dot println that distance centimeter. Now serial print distance inch, right? So now serial println that distance inch. Now delay. Let's give 2 seconds. So let me verify it first. Okay, now let's move to the hardware part. It connects the sensor first. So let me connect the sensor with ESP32. So first, VCC pin has to be connected with V5, which is 5 volt, and then ground pin with ground, and the trigger pin number is fifth pin, which is here, and echo pin is echo pin is 18, right? So 18 here. So this is our connection. Let me upload the code first. Yeah. Open a serial monitor. So this is approximately calculating the value. So if I move my hand near to the sensor in the sense, it will show like distance is 6.51 centimeter and the inch is 2.56, right? So if I move my hand a little longer in the sense, it will calculate like 12, 13, and now 17. If I move my hand closer in the sense, like 5, 4, or 2. Yeah, this is our output. Now let's move to the next topic. Now we are going to see how to interface ESP32 Bluetooth. So first let me give an introduction about ESP32 Bluetooth. So Bluetooth is a great wireless communication technology that has been popular for quite a few years. Operating in the unlicensed 2.4 GHz ISM, which is industrial, scientific and medical frequency band, Bluetooth is a short-range wireless communication technology with range of 200 meters. So ESP32 supports both classic Bluetooth and Bluetooth low energy, which can be configured with Blue Droid Bluetooth stack. So ESP32 Bluetooth supports three types of host controller interface. One is UART, SPI, and another one is virtual host controller interfaces. Only one can use at a time, and the UART is the default. Then coming to ESP Classic Bluetooth, here we are going to this Bluetooth. So this Classic Bluetooth, also known as Bluetooth base rate or enhanced data rate, is the original point-to-point network topology designed for one-to-one wireless communication between master and slave. Even though multiple slave devices can be connected to a single master, but only one slave can be actively communicating with the master. Our Bluetooth keyboards and mouse work with classic Bluetooth technology. Another simple example is file transferring between two devices like two mobile phone or a laptop and a mobile phone over Bluetooth is based on classic Bluetooth functionality. The communication between ESP32's processor and Bluetooth controller is based on serial interface. So ESP32 classic Bluetooth serial communication means if you ever work with Arduino and any Bluetooth devices like HC05, then you might remember that Arduino, Uno and HC05 communicate over serial communication. ESP32, which already has a Bluetooth controller, also has a similar communication between the main extensor processor and the Bluetooth controller. What this means is that after receiving data from a Bluetooth device wirelessly, the Bluetooth controller in ESP32 transfers this data to ESP32's processor over serial communication. Similarly, in order to send data over Bluetooth, the processor of ESP32 transmits data to the Bluetooth controller using the serial interface. So we will use this information along with a dedicated Bluetooth serial library to transmit and receive data. So this library works similar to the serial library, but it is just with the ESP32. Some of the frequently used functions offered by this library are like a begin, available, write and read. So now let us write a simple code which transfers data between ESP32 and a mobile phone. To receive the data of ESP32, we are going to print the data on a serial port. Coming to the mobile phone, in order to send and receive data over Bluetooth, we have to use an application. So just go to Play Store and download serial Bluetooth terminal application. So now let's move to the code part. Open your Arduino IDE. Okay, let me erase it first. First, I am going to include library called Bluetooth serial.h. Then now what I am going to do is I am going to check if Bluetooth configurations are enabled in the serial data or not. So for that I am going to give if not equal to define config Bluetooth enabled or define config blue droid enabled. So now error. So if not in the sense, then it will throw an error. Right? So for that I am going to give error. Bluetooth is not enabled. So please run this make menu config to and enable it. Now I am going to end this. Now Bluetooth serial BT. So Bluetooth serial is created as serial BT now. Now inside void setup, I am going to start with baud rate serial begin. Then I am going to start serial BT begin. Then I am going to print a message like Bluetooth starter. It's ready to pair. So now coming to void loop. First I am going to give if condition like if anything is available. So serial dot available in the sense I am going to read it. Serial BT, right? So serial BT dot first I am going to write and then I am going to read. So it waits for input from either the serial or the serial BT interface. When input is received in the sense from one interface, it is written to the other interface using the write function. For that, I just created like serial BT dot write inside the bracket serial read. So now another if condition. Again, I am going to give serial BT dot available same serial BT serial write inside serial dot read. So outside value just give a delay. So first let me verify it. Okay, now our code is error free. Before that, make sure that you are connecting the correct board and port. Now let's move to the hardware part. So here I have connected the positive and negative side of the Bluetooth into the 5 volt and the ground pin of the ESP32. So now let's upload the code first. Now connect the TX and RX pin into ESP32. Now open your serial monitor and just reset it. Yeah, here it will show like Bluetooth started is ready to pair. Now make sure that you have turned on Bluetooth in your mobile phone. And now open the software. Here just go to the terminal here, devices, pair your ESP32. Here it will show like connected. So just like send hi ESP32. Yeah. Here it will show like hi ESP32. Now we are going to send like hi BT here in the sense. It will receive hi BT here. So this is our output. We can send and receive messages from laptop to using Bluetooth to a mobile phone. So now we are going to write code for controlling LED using ESP32. So for that, the same code, but we just have to modify that. So let me write it from first. So same include inside Bluetooth serial.hash library. Then I am going to define LED pin as 2, and then I am going to give Bluetooth serial as serial BT. Now I am going to create a variable called Bluetooth data as a byte. So now again we are going to check if Bluetooth configurations are enabled or not. For that, same if defined config under BT under enabled, or defined config blow droid enable. So again error Bluetooth is not enabled, so please run make menu config to enable it. So then end if. So coming to void setup, instead I'm going to mention the pin mode output, right? So again I'm going to serial dot begin 115200. So now serial BT dot begin. Now I'm going to print like a message like Bluetooth starter is ready to pair. So now coming to void loop, first I am going to check any data is available or not. So serial BT dot available. So inside, if available in the sense, I'm going to store it in a variable called BT data. So serial BT dot, I'm going to read it now. Serial dot write inside BT data. So now I'm going to make a condition called if received character is 1 in the sense, then I'm going to turn on my LED. If 0 in the sense, it has to turn off the LED. For that, I'm going to make a condition. So first, if that BT data gets 1 in the sense, digital write LED pin has to become high. If that Bluetooth data 0 in the sense, digital write off LED pin has to become low. So this is our code. Let me verify it first. Okay, our code is error. So now let's move to the hardware part. So the same connection, extra, I have added LED and resistor here. So we have mentioned second pin as LED pin, right? So make sure that you connected the correct pin and ground. So now let me upload the code. Before that, just remove this TX and RX pin. Upload it now. Yeah, it's uploaded. Now connect your TX and RX pin. So now open your serial monitor. If reset in the sense, yeah, Bluetooth starter ready to pair. If I send again, make sure that it is connected. So ESP32, yeah, connected. Now I'm going to send 1. So the LED is high now. So if I send 0 in the sense, the LED will be off. So 1 will be blink, 0 it will be off. So the same thing has to be printed here. So 1, 0, 1. You can see here, right? So this is our output.